Okay, chapter 3, video 2. So looking at compounds and their weights, we call these formula weights or molecular weights. And what you're doing is you're looking at a compound and coming up with its formula weight using the periodic table. So if you're talking about a single atom or molecule, then you're going to be working in the unit atomic mass unit, which is AMU. Later, we'll talk about what a gram is, which is more of what we generally use. But an AMU is just a very tiny unit of mass. So here, we're going to always round to 2 decimal places is what our normal is going to be. So you go to the periodic table, calcium is 40.08. There's only 1 calcium in the formula, and there's 2 chlorines, so I'm going to do 2 times 35.45. We add these together, and our total comes out to be 110.98. Once again, we're going to keep 2 decimal places. Calcium phosphate, there's 3 calciums, so I'm going to add 3 times 40.08. 2 PO4s, so 2 phosphoruses, that's the 2 times 30.97. And then actually 8 oxygens, so 2 times 4 is 8 oxygens, 8 times 16. We'll add these all up, and 310.18 AMU. Percent composition is telling us how much of a compound's mass is due to each atom. So you'll use this formula. You take the number of that atom in the compound, multiply it by its individual mass, and then put it over the total mass of the compound times 100. For example, if we're looking for the percentage of chlorine in CaCl2, there's 2 chlorines in the formula, so we say 2 times 35.45 over the total mass, which up here we had already seen that calcium chloride had a total mass of 110.98 times 100, and we see that chlorine makes up 63.89% of that compound's mass. Here, if we're looking for percent by mass of calcium and calcium phosphate, we do 3 times 40.08 because there's 3 calciums. We already calculated up above that this full compound had a mass of 310.18 times 100, and we get 38.76%. Okay, then we move to this thing called the mole. So a mole is kind of like a dozen, where a dozen of anything means 12, whereas a mole means 6.02 times 10 to the 23rd. So it's just a very, very large number. So it can be objects, it can be molecules, atoms, compounds, etc. It could be shoes. 1 mole of shoes would be 6.02 times 10 to the 23rd. That is a humongous number. So we can use this as a conversion factor. It's helpful for us because when you're working with a small sample of atoms or compounds, you have easily a mole of atoms or compounds, even in a tiny sample. So here if it says how many K atoms are in 4.33 moles of K. So you start with what you know. This is going to be very similar to last chapter. 4.33 moles, automatically the unit mole has to come to the bottom. By the way, the shorthand is just to remove the E, is fine. So mole comes to the bottom to cancel. And then I put 6.02 times 10 to the 23rd, and I should have written atoms here on the top because this conversion factor is the same, meaning it's equal to 1. 1 mole is the same thing as 6.02 times 10 to the 23rd. You multiply the tops, and here is our number of atoms. Then it says how many moles of calcium are in 6.44 times 10 to the 22nd calcium atoms. So this time we're starting with atoms, which means atoms have to go on the bottom this time, and moles on the top. Once again, think about a mole as a dozen. 1 mole is made up of 6.02 times 10 to the 23rd atoms. I don't think I said this a minute ago that this is called Avogadro's number. So we'll use Avogadro's number to get in and out of moles and individual atoms or particles. Whenever you're dividing by scientific notation like this, remember to use parentheses on the bottom. Make sure you're getting to the same answer as I have here. How many moles of water are present in 5.43 times 10 to the 24th water molecules? This time we're starting with molecules, which means molecules have to go on the bottom. Once again, molecules are just another type of particle. So it's a number of things in 1 mole. So we divide by Avogadro's number and we get 9.02 moles. How many compounds are in 1.25 moles of sodium chloride? We start with moles. The mole has to come down to the bottom. We put Avogadro on top this time, and we multiply. So remember, mole and Avogadros, they can go top or bottom based on what we're starting with. Then if we kind of understand a formula, so calcium nitrate we know has 1 calcium and 2 nitrates. So here it says 1 mole of calcium nitrate contains how many moles of each of the individual? It contains 1 mole of calcium, 2 moles of nitrogen, and 6 moles of oxygen. Because anytime you have a number, a subscript outside the parentheses, you're going to distribute that through to each atom inside the parentheses. And then we can use that as a conversion factor. Like 1 mole of calcium nitrate has 1 mole of calcium. Or 1 mole of calcium nitrate has 6 moles of oxygen. So you can set those equal to each other on top of one another in a conversion factor. So 0.25 moles of calcium nitrate, and we're looking for moles of nitrogen in particular. So we put moles of calcium nitrate on the bottom, and then we put moles of nitrogen on the top. And what we just agreed on was that 1 mole of calcium nitrate will contain 2 moles of nitrogen. That's because of the formula. That's where we got this conversion factor from. So we multiply by 2, and that gives us the moles of nitrogen atoms. It says how many atoms of nitrogen are in, oh, so this time it's asking atoms rather than moles. So how many atoms of nitrogen are in 0.25 moles of calcium nitrate? So start similarly, 0.25 moles of calcium nitrate, and we get to moles of nitrogen from the formula because 1 mole has 2 moles of nitrogen. That's the same step that I just did previously. I just wrote it again. Now that we're in moles of nitrogen, we can get to nitrogen atoms. So we bring moles down to the bottom, and we get to 6.02 times 10 to the 23rd atoms up here. And then we multiply by all the tops, divide by the bottoms, and we're in atoms. So make sure the moles and the compound cancel. Moles of the atom cancels, and we're left with just nitrogen atoms. And one more that's similar to that is how many sodium atoms are present in 1.50 moles of sodium carbonate? There are multiple ways to do these problems, so if you see it differently, go for it. Just make sure we're getting to the same answer. Here's my moles of sodium carbonate. I know that in each mole of sodium carbonate, there are 2 moles of sodium because of the formula. And then I bring mole of sodium to the bottom. And I know each mole of sodium will contain 6.02 times 10 to the 23rd sodium atoms. So then we multiply and divide, and we get to our answer. Molar mass can also help us a ton, where molar mass is the mass of 1 mole of a substance, and it's also based on the periodic table. So the molar mass of an element is just the mass of a periodic table. We're still going to go to 2 decimal places, but now it's in grams rather than atomic mass unit, okay, because this is a mole of a substance. So for example, if you have 1 mole of carbon, what that means you have is 6.02 times 10 to the 23rd atoms. You no longer have a single atom of carbon. You have 6.02 times 10 to the 23rd mole atoms of carbon. That is what 1 mole is. And that 1 mole would have a mass of 12.01 grams. That's because that's what's on the periodic table. So if you went in the lab and massed 12.01 grams of carbon, you would know that you have a mole of carbon. Similarly, for a molecule, you're going to add up each of the pieces. So 1 mole of calcium, you're going to take 1 calcium, so 40.08, and 2 fluorines, 19.00. Add them up. We're trying to keep consistent with 2 decimal places, and our mass is 78.08. What that means is if you went and got 78.08 grams of calcium fluoride, you would have 1 mole of calcium fluoride, which means you really have 6.02 times 10 to the 23rd calcium fluoride compounds. And then one more, calculate the molar mass of calcium nitrate. So 1 calcium, 2 nitrogens, and 6 oxygens. And we get 164.10. So then what we'll see is that we can use both the molar mass and Avogadro's number to bounce in between different units and amounts. So here we now know two different calculations that we just learned. We first learned Avogadro's, which was moles to individual pieces. And each mole consists of 6.02 times 10 to the 23rd atoms, molecules, ions, compounds, etc. We also know how to convert between grams and moles over here because we can use the molar mass on the periodic table by adding up the individual masses to make the molar mass.